Alright, so today we're going to be doing 13.5, which is systems of inequalities. So, first thing we're going to do is we're just basically going to graph both of these sets of inequalities. And when we do that, we are going to find what the shaded regions are, and we'll talk about what they represent. So for the very first one, okay, I'm going to start at the y-intercept, which is at 3. And then I'm going to go up 1 and over 2. Gotcha. Okay, here you go. So for the first one, I'm starting at the y-intercept, and then I'm applying that slope. So I started at 3, and then I go up 1 over 2, up 1 over 2. And I'm going to continue doing that until I get enough points that I have a general idea of what it looks like. Then I look at the inequality, and I determine that it's going to be a solid line. So since it is going to be a solid line, I can go ahead and connect. And then I determine if I'm shading above or below. So in this case, I'm going to be shading above, below, because it is less than. Since it's less than, I'm going to be shading below. Just picking a better color. There we go. So it's going to look something like this once you do it. Now we're going to go ahead and graph the other one. So in order to graph the other one, I'm going to start at the y-intercept, which is at 1. And then I'm going to apply the slope. I'm going to go down 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then I can get a few points the other direction as well. And then I would determine if it's a solid or dashed line. What do you guys think? Dashed, because of the inequality. And then, are we going to be shading above or below?
Above.
Above, because it's greater than. Alright, so now I'm going to talk about what all of this means. So any point in the non-shaded region would represent a point that satisfies neither inequality. Anything in the pink satisfies only this inequality. Anything in the double shaded region satisfies both inequalities, any point. And then here, anything only satisfies the first inequality. Now, because the blue is a solid line, any point on the line would satisfy the blue. But any point on the dashed line would not count, because the dashed line is like a boundary that we can't actually apply. Because, for example, if we plug, it would be like 5 is greater than 5. It doesn't work because the equal sign isn't there. So that's what all of that means on the graph. So does anybody have any questions about that? All right, perfect. All right, so for the next one, we'll start the first one by graphing the linear equation. So we start at 1, and we go up 1 over 1. And we're going to do that a few times until we see what the line looks like. And once again, the line is going to be dashed because the inequality doesn't have an equal sign underneath it for this first one. It's greater than, so we're going to shade. What do you guys think? Above. And then the second one you're going to notice is going to be a quadratic. So I make my table. So to find my axis of symmetry, it's negative b over 2a, but what do you notice about this function? It's missing what? A b, so the b is just 0, so it's just going to be 0 for my x-coordinate, which means if I plug 0 back in, I get negative 3. And then I go back 2 values and up 2 values. So I'm going to plug in 1. So I get 1 squared minus 3 is negative 2. I got 2 squared minus 3 is 1. So this is negative 2 and 1 as well, by just plugging those values into the function and getting a y. Now I'm going to graph them, so negative 2, 1. -1, -2, 0, 3, and so on. Is this going to be solid or dashed? Dashed. Okay. And am I shading above or below? Below. All right, does anybody have any questions about this inequality? So if I asked you to pick a point that satisfies neither inequality, what would you tell me?
0, 0, 0.
That works. 0, 0. What about a point that satisfies both inequalities?
Negative 5, 0.
Yep, that works. -5, 0 would work. Perfect. Okay, so you get the idea here. There's two little sections that would satisfy both. All right, cool. You ready for the next? All right. So for the first one, we're going to start by graphing the linear equation. So -3, and then I go down 2 over 1. And I do that a few times. Is this line going to be solid or dashed?
Solid.
Solid, good. Oh, wrong color. Okay. All right, and is it going to be shaded above or below? Above. Okay. For the second one, make our table. Vertex is going to be -4 over 2, which is -2, correct? If I plug -2 back in, I get 4 minus 8, which is -4, plus 6 is 2. And then if I plug in -1, I get 1 minus 4, which is -3, plus 6 is 3. And if I plug in 0, I get 6. So now I can graph these. And it's going to be dashed. And what direction am I going to be shading here? Above or below? So any questions about that one? No? All right. The next one is both quadratics. So for the first quadratic, I'm going to do it in purple. So my axis of symmetry is going to be -6 divided by 2a, so it's 2, so it's -3. And then I plug -3 back in. I get 9 minus 18, which is -9, plus 12 is 3. If I plug in a -2, I get 4 minus 12, which is -8, plus 12 is 4. And then if I plug in -1, I get 1 minus So it's going to be negative 5 plus 12, which is 7. So once I have those points, I can graph them. And is it solid or dashed? Dashed. Shading above or below? Above, good. Alright, now here's the problem with the next one. When you go to find the axis of symmetry, you're going to get negative 2. When you plug negative 2 back in, you're going to get 4 minus 8. So it's going to be negative 16. What's the problem with negative 16 being my y value? It's not on the graph. So if you were to make that table, you're going to get a bunch of values on this function that are not on the graph. So here's what I'm going to do instead. Now, if this ever happens to you, you have different options. You could, of course, just start plugging values in that you know are on the graph. But what I'm going to do is, does this quadratic factor?
Yeah.
Yeah, what's it factor into?
2 and 6.
Good. Positive 2 and, I'm sorry, positive 6 and negative 2, right? Which gives me x equals negative 6 and x equals what? 2. These are our zeros. These are our x-intercepts. So I'm going to instead graph those x-intercepts because I know those are going to be on the graph. Now this gives me some information, but not quite enough. So I'm going to try to get some more information by plugging some numbers in the middle here. I already tried all of these, so maybe try something that's not one of these, right? But I do have these two, that was from the other function, oops. So what I want to try to do is, what if I plug in a 1 into the function so I can see what this value is going to be? So 1 squared is 1 plus 4 minus 12. That's going to be negative 7, right? So this is going to be at negative 7, which means that there's a symmetrical point on the other side that's also going to be at negative 7. But if you don't believe me, you can plug in negative 5 and test it out. Now this at least gives me some information because I know the vertex is going to go off the graph down here. So I at least have enough information to see what my graph looks like. But what the idea is, I don't have that bottom part of the graph. Do you all see what I'm saying by that? It just goes off the graph, unfortunately. So that's somewhat of what it's going to look like, okay? Now, which way are you going to shade? Above. What do you notice about the first graph? Yeah, so basically there's no section that is just pink. Okay, there's only an overlap in the blue and the none. So what I want you guys to try to do is, why don't you all try number 5 on your own, and then I'll put up the answer so that way you can practice. Rodrigo, do you want to hand out the homework for me if you have a chance? Thank you.
I know what you're talking about.
Like they're all gonna be like right here, like in no space.
Yeah, it's stressful because they're all around you.
Yeah.
Like they all. do
And
the
it's just
same.
also like there's not enough room over here. It's just like too crowded.